because this would be good to mention in the recording. Okay, so section 1.6 deals with applications of linear systems. And we're going to be covering two applications in the lecture. One is dealing with chemistry, and the other is dealing with an economic problem, homogeneous systems in economics. The third type problem you'll be responsible for is network flow. And network flow, they have the second example in My Math Lab talks about that. So let me give you a moment to copy this problem down. How many remember balancing chemical equations in chemistry? Maybe from high school or, okay. And how many remember the tough ones, right? That you need to get integers and, okay, Kevin remembers that. Well, with linear algebra, this is going to be an easy process to balance a chemical equation. All right, I'll let you copy this down. Okay, so what we have here is a chemical reaction, and we have two molecules on the left here mixing. Of course, O2 is oxygen. Does anybody remember what C3H8 is? That's right, Binyam, that's propane. So if you combine propane with oxygen in the right amount, you're going to get, as a result, CO2. CO2 stands for good, carbon dioxide, that's right. And of course, H2O, we know what that is, water. That's right. So we want to balance the chemical equation. And for some of the chemical equations, the easier ones, it's not too hard to balance them. But for when it gets more complicated, it can be a little bit of a chore. But with linear algebra, we can make this a very simple problem. So what we need to do is we need to represent each of these molecules here as vectors. Okay. In the chemical reaction, we want to represent each molecule as a vector. How many atoms are there in this between the molecules? How many different atoms are there? How many? Is it 4? It's going to be 3. Three atoms. You have carbon, That's right, 3 different types of atoms. That's right, Binyam. Hydrogen, carbon, and oxygen. So, and if you don't mind, I'm going to do it in the order of carbon, hydrogen, and oxygen. So, in the solution, what do we need to find? I mean, this here is when we say balance the chemical equation, that means find x1, x2, x3, x4. Find those coefficients so that the chemical reaction takes place. But what we're going to do is we're going to denote vectors to represent the molecules. So you have the propane molecule here and the oxygen molecule there. Okay, let me give you a moment to catch up here on the notes. Okay, so here are our 4 molecules, the vector representations. So for instance, the propane molecule, C3H8, for propane there are 3 atoms of carbon. So in the carbon spot we put a 3. H will be in the second entry. There are 8 atoms there. And then there's no oxygen. 0 atoms of oxygen. On the other hand, for CO2, carbon dioxide, there's 1 atom of carbon. There are no hydrogen atoms, 0, and there are 2 oxygen atoms. Okay, so, and then, you know, oxygen and H2O, those vectors are as they are. The order, Moshe, does not matter. It does not matter, but you have to be consistent in the vectors. So like, for instance, I have my carbon atoms in the first, my carbon atoms are in the first entry. Like based on the propane molecule, carbon atoms are in the first entry. Hydrogen atoms are for the second entry, reserved for the second entry, and the oxygen atoms are reserved for the third entry. So I have to be consistent then with my other vectors. But, you know, if you wanted to have your, oh, sure, you're welcome. If you wanted to have your oxygen be in the first entry and carbon in the second and hydrogen in the third, I mean, that's okay. All right, are there any other good questions? All right, well then, so to balance the equation, so all the material gets used up, All right. We need to solve this vector equation here. Which is a match, right, with the, it's a match with the, you know, what you'd see in chemistry class. Okay, so please let me know if you have any questions. All right, so we get this vector equation here at the bottom. And what do we want to convert then the vector equation into? A matrix. That's right, Solomon. We want to convert it into, well, it is a matrix. We can convert it to a matrix equation, and then an augmented matrix, and it will indeed be a homogeneous system of equations. So we need to solve for x1, x2, x3, and x4. So how many equations are going to result from this vector equation? How many equations will there be? That's right. Thank you, Solomon. There'll be 3 equations. That's right, Divahar. And let's, assuming the equations are all different, what's one of the variables going to have to be? That's right, Matthew, free. That's right, Solomon, free. So, you know, you have 3 different equations, but 4 unknowns. You're going to have a free variable. So we'll move on then to the next page. That's okay. And I usually, you know, in class, see what I would do is I'd be looking to see you copy the notes, and I would see that everybody has the notes down before I move on. But of course, with remote learning, I have to ask more frequently. I just have to ask to make sure. But I think everybody's good. Let's move on. So this vector equation here is, of course, I gotta manipulate that vector equation, right? I gotta manipulate that a little bit. So the x3 times 102 vector, I can subtract that over to the left side. And the x4 times 021 vector, I can also bring that over to the left side. I can subtract it from the right side and the left side. Okay, so what we would get then is this system of equations. Okay, so let me just see here one moment. So that, of course, comes from x1 times 3 a and 0 plus x2 times the vector 0, 0, 2. That's a 2 there. Okay, minus x3 times 1, 0, 2. So I'm filling in a step for you here. It's an important step. I should have put it in the notes. Minus x4. Well, I am putting it in the notes, right? It's here in the recording, but minus x4 times 0 to 1. And that whole thing is going to equal a right side of zeros. So the vector equation on the previous page, then, remember we had two vectors on the left of the equation and two vectors on the right of the equation. Well, what I'm doing is I'm bringing over the two vectors on the right of the equation to the left side. That's why we have minuses on those two vectors there. And then that's going to equal, well, on the right side, you're going to have a column of zeros. And then this vector equation here will then be understood to be this system of equations, this homogeneous system. Are there any questions on that? So far, so good, Sega. Very good. Okay, Vivian's comfortable. Robin's good. All right. Well, so now, thank you, Christy. Thank you, Francesca. And now we're going to take our system of equations and write it as an augmented matrix. So what we can do, of course, we can do the row operations, work them out by hand for this. It wouldn't be a problem, but let's go ahead and take a look at MATLAB. Sometimes these problems, these application problems, can give you pretty matrices. And I want to show you how to work with MATLAB on this. I sent an email out earlier today about, if you had time and if you got the email to try to load MATLAB on your personal computer. But whether you have it loaded or not, yeah, online MATLAB's fine, Divahar. If online MATLAB, you mean the one that's part of the virtual desktop interface? Is that what you mean? And Divahar, where do you access so there is a MATLAB that's online, virtual desktop interface. Where, Divahar, do you access that? The virtual desktop interface. That's through MyMC, I assume. let me make a note here. Maybe I can investigate. We'll talk later about logged into account. So Divahar says that he logged into his account on MATLAB. Oh, and it gave him an option for the online one. Okay, all right, that's fine. So now one thing I'll mention, when you use the virtual, I personally think it's better to download the MATLAB, because I've heard from students that when you use the virtual desktop, of course, if you're doing a program and you don't save it, then I think it can get erased on the virtual desktop. Well, you always need to save your program. I mean, you should always save your program. But I've heard that from time to time there can be issues using different kinds of issues using the virtual desktop MATLAB. But you know, maybe not now. You know, so Solomon thinks the downloaded one's better. That's fine. So I'll leave it up to you. Let me go ahead here and go into my MATLAB. So Divahar, MATLAB is very, I mean, you can go to Google, certainly, and if there's something you need to find on MATLAB, you can type it in Google, and usually it'll bring up manuals and, you know, examples and things like that. It's not a big issue. You know, so you'll be okay right now for this simple stuff we're doing here. So I'm going to go into application here, and this is what the MATLAB should look like. Okay, so do you all see my MATLAB here? Everybody's good? So here it is. Thank you, thank you. So, you know, the way this is what's called your command window on the right. Okay, this is called your command window. And on the left is like variables. So like, for instance, if you were to, hold on here. If you were to type like v equals 5, and you hit enter, you see here how in Workspace it's going to store the b there as b equals 5. And if my understanding is correct, normally, like if you download the MATLAB on your computer, I believe it's going to save that. But the virtual desktop, I'm not sure. Okay, but you know, but don't, you know, I'm pretty sure it saves it for the downloaded MATLAB. Now, if you want to clear out the variable, you just use the command clear vars, and that'll clear your variables out. Okay, and sometimes that's good to do because people tend to use the same variable name for things, and there can be conflicts. I mean, well, traditionally what happens is when you use the same variable name and you reassign it to something, it'll replace the old variable. But, you know, clear variables is very nice, right? Because then I got a clean slate on the left. Now what I'm going to do is I'm going to type in this augmented matrix. So I'm going to use a capital A equals, and how do I do this? I put in the rows. Okay, that's the first row, 3, 0, negative 1, 0, 0. And then I use a semicolon, and then I'm going to type in the next row, 8, 0, 0, negative 2, 0, semicolon. And then the last row is 0, 2, negative 2, negative 1, 0. Okay. Hopefully I've typed everything in okay, and I'll hit enter. And see, now it has A up there in my workspace. Okay, so this is my matrix. Now what we want to do is we want to do row operations on the matrix. We want to get the matrix, this augmented matrix, which represents our system of equations. We want to get that in reduced echelon form. So what you do is you use the command rref, of A. Okay, RREF of A, that's row reduced echelon form. Hit enter, and it gives you the reduced form. One moment, let me just hold on here. There is something missing here. Hold on. One moment. It happens. One moment. Okay, so this is what let me just see here. Okay, hold on. Now let me go back to here. There's a few. Okay, so is everybody good so far with what they're seeing here? All right. Now, it's giving decimals. Thank you, everyone. It's giving decimals, and I like to have fractions, and you know MyMathLab likes simplified radical form. So what I'm going to do is use the command format RAT. Format RAT will give rational format, fractions. I'm going to hit enter, and then I'm gonna bring that command up again. If I just use my up arrow on my computer, it gives me the command back. Whoops, I want to go back actually to RRAF. Okay, so I'm going to do that again, and now I have the augmented matrix in reduced echelon form with the fractions, which I'm more comfortable with. Okay. I mean, you can't always get nice fractions, but here we can. Okay, so everybody's good so far? All right, well, what we're going to do, let's go now back to, I mean, basically I've used MATLAB. They're helpful, yes, Binyam. We've used MATLAB now to get the augmented matrix in reduced echelon form, so I'm going to go back to the notes and put in the reduced echelon form. Let me just see if there's anything else maybe I can answer here. I mean, I think, you know, oh yeah, I'll mention one thing here. So in MATLAB on that FX, to the left of the arrows here, there's an FX. Click on that, and it gives you categories for help. Different categories, okay, for help. So like, for instance, if you typed in reduced echelon form, okay, see, I typed that in, and then it shows that RREF command. Okay, so that's a very helpful feature. The help's very convenient. It's right there near the command line. So, okay. All right. Okay, all right. So that being said, then let me bring back our example here. I think it's great too, Solomon. So Binyam, Excel, the thing is, I'm not saying you couldn't do this on Excel, but the well, Gauss-Jordan elimination is what we're doing when we do reduced row. Well, hold on. So we want to use MATLAB. MATLAB is what's required in our 200 level courses, also for the courses to transfer. Other institutions want you to have some expertise in MATLAB. So that's what I want you to use. Please don't use Excel or anything else. Get used to using MATLAB. You're going to have some MATLAB assignments coming up, and in the assignments, I'm going to want to see your MATLAB code. So MATLAB is what I want everybody to use for you know, when you have like you know, when you have, you know, when it is necessary to use it. Let me just see here. Hold on. A few questions. Okay. And yeah, Matthew, Gauss-Jordan elimination is the same as the row operations, reduced echelon form. Okay, so good questions. Let's get the example up here. Hold on here. So back to the chemistry problem here. Okay, so actually here, I don't want to say next page yet. So I want to say using MATLAB. Using MATLAB, our augmented matrix reduces to, okay, and let me write down what MATLAB gave us here. So 1, 0, 0, -1/4, and 0 for the first row. 0, 1, 0, -5/4, and 0 for the second row. And then 0, 0, 1, -3/4, and 0 for the last row. Okay, reduces. Okay. So now write down what, so what do you want to be your free variable? What makes sense to have as your free variable? X1, X2, X3, or X4? X4, definitely. So go ahead and write out X4 as free, and then write down what X1, X2, and X3 are. Okay, and you should have, well, I'll give you another moment here. Okay, you should have then you should have this. Excellent. Excellent. Well, now we have values. Well, we can't, of course, could I say that x4 equals a half? Could I let x, I mean, x4 is a free variable. Could I let x4 equal a half? No. Well, we can't because we want to balance this equation. I mean, if it were just a math problem, sure, we could, because x4 is free. But we are applying, this is an application, and x4 is the coefficient that comes in front of the H2O, and we need that to be an integer. We would be violating chemistry laws if we didn't use integers. So since the coefficients in a chemical reaction must be integers, okay, since the atoms per molecule is an integer, we'll let x4, well, I'm going to let x4 be 4. Okay? I'm going to let x4 be 4. Now, why did I let x4 be 4? Why not let x4 be 20? I'm choosing x4 to be 4, or what? Yeah, that's right, Matthew. It's the simplest. So when you do these problems, you want to, even though there are like many answers that would balance the equation, you want to pick the simplest answer, and that's what my math lab's going to want. So and being you have fourths here, 5/4, 1/4, 3/4. For x1, x2, x3, you have the factor of coefficients that have a 4 in the denominator. Let x4 be 4. Then x1 will be 1, x2 will be 5, and x3 will be 3. And so you've balanced the equation. And you use the smallest possible numbers. How many think that's a pretty cool application of linear algebra? Yeah, absolutely. Thank you. Thank you. Yeah, so next time you have to balance an equation, hey, you won't, you'll be able to do it very nicely. Are there any questions before we move on? I want to do another application. The final answer then, since, okay, so x1 was 1, so I'm going to put a 1. Let me just clear this. Okay, so x1 was 1. So a 1 goes in front of the propane molecule. x2 is 5. So a 5 goes in front of the oxygen molecule. x3 is 3. So 3 goes in front of carbon dioxide. And x4 was 4. So 4 goes in front of H2O. Okay, so this is your balanced equation. 1 molecule of propane plus 5 molecules of oxygen will yield 3 molecules of carbon dioxide plus 4 molecules of H2O. The one thing I would say, question was asked about hints to choose the simplest numbers. The fact that you have a 4 here in the denominator for x1, x2, and x3 leads me to let x4 be 4. That would be my way of thinking about it. Sega, are you comfortable with that? I think it was Sega who asked that. Okay, great, great. Okay, well, let's go ahead then. May I move on to the next example? Are there any more questions? Okay, Christy's good. Sega's good. All right, Diva, all right, wonderful. Well, then let's move on here. Thank you, Vivian. Yuan is good. Okay, let's do a little economics. All right, Francesca's good. Let's do a little economics. So I'm going to give you a moment to copy this down, this problem. The book does an economics problem dealing with coal, electric, and steel. It's a good problem, but I want to just work with this problem here. So let me give you a moment to copy it down. All right, so we'll talk in just a moment. And is Michael Betray here? He had a question, but okay. Well, hopefully he will. Is Michael Betray here? Are you one of the two callers? Just maybe, you know. Okay. Okay. So thank you, Michael. So I sent you an email, and I had thought maybe you weren't in class session, but ignore my email now that I see you are. Um, uh, so just a quick thing. Michael tried to download MATLAB. Are you okay, Michael, if I mention this to the class? Because I'm not a student, I don't have the student experience of. So Michael tried to download MATLAB on his PC computer, and I guess it asked him for a license or an activation key. I am familiar with those things, but I didn't know that students needed those because I thought students got it free. Solomon, you had that issue. So did anybody? Okay, Diva Hirsch says you have to make an account on MATLAB first. Okay. Um, okay, you have to make an account with MATLAB first using your MC email. Okay, so academic use. So what you could do, Michael Betray, and anybody else that's you know in the and again, this is something, since I'm not a student, I don't go through this experience. It almost has to be really like IT helping you or a student helping you. But it sounds like students have successfully done this and know and can solve this issue. So what you could do, Michael, is you could email the class. Uh, uh, I'm sure they won't mind mentioning the issue you're having, and you already have a few people chatting out things. Okay, thank you. So Noah just sent something. Let me see here in the chat. So Noah just sent something here, a link. So Michael, feel free to get that link, and anybody else, and you can always email each other. Like what you could do, Noah, is maybe if that was the link that helped you, the install guide, maybe you could, if you have time, you don't have to, but you have it here in chat. But if you feel like it, you could email the class that through the email in Blackboard. Just send email to the whole class. But I see. But if you've chatted it out here, and that's great. So please communicate with each other if for these kind of things. This is excellent. Okay, so let's see here. So in this problem, it's an application of linear systems. It says, suppose an economy has only two sectors, goods and services. Okay, so goods and services. All right, so each year goods sells 80% of its output to services and keeps the rest. So, services like plumbers, carpenters, trying to think of, there are a lot of different service occupations, electricians, people that provide services need goods to provide those services. You need tools, for instance, okay? So goods sells 80% of its output to services and keeps the rest. So goods keeps 20%. So if goods, for instance, sells tools, makes and sells tools, well, then it's going to keep maybe 20% of the tools it makes to help it make more tools. You see. Services, on the other hand, sells 70% of its output to goods and retains the rest. So services is going to, goods, the company or the factory that makes the goods is going to sometimes need services. It's going to need service people to come in and maybe calibrate the machines, oil the machines. Maybe some lighting needs fixed to keep the factory in good shape. So, but services will retain the rest. So services might need some services then to help it stay, in business as well. So, I want to say this the right way. So I can't, offhand, I can't think exactly of what services would need to retain. It says services retains 30% of it. I know that, but hey, I'm sure if we think long enough, we can think of something. But I'm just trying to make this sort of intuitive to you, a little bit intuitive. Like services, if they have trucks that need to go out, they have trucks, right? That carry technicians out to the factories to help the factories that make the goods. Well, the services need to service their trucks, you see. So that sort of thing. So what we want to do is we want to find equilibrium prices for the annual outputs of goods and services sectors that make each sector's income match its expenditure. Okay, so we want to find the equilibrium prices for the annual outputs of goods and services sectors that make each sector's income match its expenditures. So we want the economy to be what's called equilibrium. Okay, so I will move to the next page if that's okay. Is anybody still copying, or are we good? Okay, all right. So, all right, well, first of all, what are these equilibrium prices? Equilibrium prices are prices such that the income of each sector exactly balances its expenses. Okay, that's what equilibrium prices are. Okay, so we don't want companies to go out of business. So they won't go out of business if the company's income matches its expenses. It will not go out of business. It will, I guess, break even, but it won't go out of business. Okay. Now, profit and stuff like that, that's more advanced. We're just worried about, homogeneous systems and economics. Okay, so what we have to do is we have to create what's called an output distribution table. And that's what I have here. Output distribution table for this economy. And that's what we have. Now this is a 2x2 table because you have services and goods. If you had 3 portions to the economy, you would need a 3x3 table. But it said in the problem that goods sells 80% of its output to services. So that means services here purchases 80% of goods. That would make sense because goods selling 80% of its output to the services. But then the other 20% of goods that the goods produces stays with the goods sector. Services sells 70% of its output to goods and retains the other 30%. So let's make sure you're comfortable with this table. Let's see if there are any questions on that. All right, well, we have to come up with a system of equations. Okay, so we can find our equilibrium prices. Well, to find the equilibrium prices, which we'll denote by P sub G, okay, price for the goods, and P sub S, price for the services. The first equation, based on our distribution table, is going to be this one right here. Income matches, the income of the services have to match their expenses. So if P sub S is the income for the service sector, that's going to have to be equal to 0.30 times the income for the services plus 0.80 times the income of the goods. Another way of thinking about it is the price for services will equal 0.30 times the price for services plus 0.80 times the price for goods. And that's just reading off the first row. You're utilizing the first row here. The second equation, okay, the second equation will be based off the second row. To find the equilibrium prices, the prices for goods have to be equal to 0.70 times the price for services plus 0.20 times the price for goods. Are there any questions on the on those two equations? Is anybody minoring in economics here, or maybe majoring in it? All right, well, you never know. So now that we have our equations, what's the next thing to do? Solve the equations. How did you relate the table to the equations? So Solomon has a good question. So like for the first equation here, do you agree, Solomon, that the income of services has to match their expenses for the system to be in equilibrium? Okay, so that means the price for services, based on the first row here, services is purchasing 30% of itself and 80% of the goods. So services is paying for its expenses are 30% of the price for services, because price is an expense, plus 80% for the price for goods. well, then you need the price for services to match that. And that's how we came up with the first equation. And similarly, the second equation would be coming from the second row. Okay, does that help a little bit? Okay, Robin's comfortable. All right, excellent. Solman's comfortable. Okay, well, now it's time to solve these equations. Thank you, Kevin. And we'll go to the next page. Everybody's copied good on this? Okay, wonderful, wonderful. Okay, well, you know, of course, what I'm going to do is, I mean, you know, I have to get, what do I want to get on one side of these two equations here? What do I want to get, like the first equation, what do I want to get on the right side? Or actually, what do I want to get on the left side of the equation? In other words, the equation, on one side, I want the variables. That's right, Matthew. And on the other side, I want a 0. That's right. That's right, Bethlehem. So what I'm going to do is the first equation here. Okay, I'm going to subtract PS, and I should say a 1 PS, from both sides of that equation. Similarly, for the second equation, I'm going to subtract P sub G from both sides. Well, let me line things up as they should be lined up. Okay, and when I do that, write down what the new equations are going to be. Okay, write down what the new equations are going to be. Okay. So then, who got these equations? I mean, I hope you all got those. But maybe give me a thumbs up if you got those. Okay. Solman did. Eva Har. Okay. Kevin. Thank you. Bethlehem, Hugh, Christy, Matthew. I'm learning all your names. Francesca. And you know, now it's time to solve this system. Max, and Rob, and Vivian, and Michael. I'm making you all famous here, right? Famous in the class. So, okay. Well, you know, I'm not going to go to MATLAB for this. This is easy. I'll just, you know, work this out by hand. So, you know, I don't like to work with decimals, so I'm going to multiply. I'm going to take the first row and multiply it by -10. And replace the first row with that result. And then the second row, I'll just multiply by 10. And replace the second row with that result. Okay, easy enough to do. I mean, there are different ways to do this. And then what I'm going to do, well, I know that we want a 0 in in that spot there where that -7 is. So I'll just add the first row to the second row. And replace the second row with that result, and that's going to give me a row of zeros. I'm not worried about getting the matrix in reduced echelon form. I mean, I could, but you know, I mean, I know that PG is going to be free variable. And then since by the first equation, 7 times PS equals 8 times PG, the price for services needs to be 8/7 times the price for goods. Okay, and so you know it's nice to make it a little more concrete. Let's say that the price of the goods, and you know I have a landline phone, it just rings. I can't like you know turn it on silent, so you just have to copy the last sentence down. Hey Alan, I'm in class now, but I'll let you talk to her a little bit. Okay. All right. I saw your text, Alan. Thank you. I saw your latest ones. I saw you searched, and I'll let you. You know. Thank you, Alan. Okay. Okay. So I'm getting back to class. Are you good, Kurt? Good, Alan. Okay, guys. Okay. All right. Bye. Okay, so if the price of goods is $7 million, then the price of services would have to be $8 million. So that just kind of gives things in context a little bit. And it is interesting because usually services can be very expensive. They really can. Some of these, like I noticed, well, I was looking at these, just out of interest, these condos over in Rockville that they're building, and it looked like they're made of brick. But I saw them constructing one, and the condos are not made of brick, they're made of wood. But what they do is they're constructing like a brick facade in front of the condo, so it looks like it's made of brick, but it isn't really made of brick. The brick's not a support, it's not like supporting the condo. The condo's itself is made of wood. And, you know, and I thought that was kind of interesting, you know. You know, normally if I see brick, I think the building's made of brick, but I guess it's not always the case. So, you know, but the prices were sure seemed high, you know. So, but anyway, what I'm trying to say is, you know, services are expensive. It costs a lot more to make a house out of brick than it does out of wood. And you know, this going over this problem just reminded me of that experience. But you know, Still nice condos, though. All right, so are there any questions on this? All right, well, what I'd like to do is stop the recording.